Welcome everyone. Today I'm going to talk about how you can build a cloud native web application, containerize it, and deploy it finally into Kubernetes. In this case, I'm going to use AKS, but you can choose to have any Kubernetes platform, all from the browser. You don't need any local setup to do that. And I'll use few of the features, and most of them are freely available to any one of us to use. So the first thing I'm going to use something called CodeSpace. So CodeSpace is a browser-based development environment available with GitHub. So if you have a GitHub account and you create a repo, just like what I did, a simple repo with no file, at this point in time, you get a tab called code. So you go to github.com, create a login, create a repo. It's fairly simple step. And after you create that repo, you basically come to this code section of that repo and see the green button called code. And in this, for the first time users, you will find that you will have no code space created. But if you say, I want to create a code space on master, it will start building up the container, create all the necessary runtime configuration for you, and make it available. So I have done that with the master branch already. So you see that. And if I click now into that, it basically opens the Visual Studio Code in browser. So you see the similar interface coming up in the browser, just like you see in your local Visual Studio. Now it is running in the browser for me at this point in time, right? So you see that this is the browser experience which I'm getting over here. Now, while I'm in the browser and I can actually bring it a little down over here just to show you that it is in the browser, you see that I also have access to the terminal. So if I go into the terminal, I get to see the terminal access and I can basically write things into the terminal. So this is the terminal, and if I hide this thing and increase the font size a bit, maybe so that you view it better. So you see that this is the terminal window, and it has things like .NET, that's .NET Core already installed. You have Docker already installed. So you have all the necessary tools and runtimes you may need for your typical development activity are all available into this uh, little box, and all in browser. Again, all in browser. You no need to install anything in your local operating system where you might have an issue with a limited memory or the local admin rights, etc. So let's first create a simple .NET application. So I'm inside this repo under a folder called sample code. Now if I say that .NET new, that's going to create a new .NET application of type web app. Okay, and then I give a name to this as sample web. Okay, you can see that it is sample web, and I will add one more switch into this just to avoid a little bit of let's say complexity into this, saying that no HTTPS, and that essentially is making sure that it doesn't require any certificate or all so on and so forth. And you can see that there is a spelling typo. That should be web, not WPP, app. Okay, so it's gonna go ahead and get the template, restore it, and make it available. Now, if you do a ls, that's the folder, you see that there is a folder inside this called sample web, which basically holds all the source code. So let me go inside that by doing sample web. I'm right now inside. Now, if I say code dot, it's going to open this Visual Studio Editor within that folder so that I am in the root of the source code folder from where I can start working on it. So it basically avoids a lot of confusion. So you can work from anywhere, whichever place you would like to. But if you are inside that folder where your source code, it becomes a bit more easier. Now, I want to show you how that .NET experience looks like. So if you say .NET build, it's going to go ahead and build the .NET project, and it will see that it's basically having all the files, folders required for that. Now, to deploy it anywhere, first thing we need is to build this as a Docker image. And to do that, we need something called Docker file. And how do you add the Docker file? Again, in the Visual Studio, you have something called an extension. And in this extension section, you can see that there is an extension called Docker, which is supposed to be installed in this. So let me install it. So the Docker extension is installed. C sharp, because this is written in using C sharp, needs to be installed. So I have both of them installed as an extension now. Just like how you do with the locally installed Visual Studio Code, you do the same thing. Now you happen to see that my source control is saying that I have got new files. So I'm kind of ignoring that. I'm not worried too much about it. But what I need is a Docker file to be created. But before I go ahead and create, I type Control Shift P. That invokes the command prompt, and I just create a task. So what is necessary about this task? I was about to tell that, hey, this is .NET application, and use the .NET task to build this application. Okay. Configure a build task. I'm just going to say task. Create a task JSON, and I choose the .NET Core task. So the task file gets created. I don't have to do anything, make any changes. I just use the command palette. Now I go to the command palette and I say Docker. Now here it is asking me to add a new Docker file. When I add a new Docker file, it asks what kind of runtime you are going to use. So it is definitely ASP.NET Core. And I'm going to create a Linux container. And remember this port 5111, which is the internal port while it want to run. So I don't need a Docker compose file because it's only one single container at this point in time. So I'm all okay. Now, once the Docker file is created, let me show you the Docker file. This all built by the Visual Studio Code, and this experience remains the same when you use something like this in the locally installed machine where you have a Docker extension there. So you can see that it picks up my CS proj, copies the file, restores it, run the build process, and then finally publishes the DLL into the image, and then run that DLL as a web app because it's a website, right? So you see the endpoint, which is line number 26, is key important part here, where it ensures that my container will be up and running. So this is what I need to make sure that it's there. So if everything is fine, I go back and run again and I can just hide this so that you have the maximum visibility. And you can see that over here, I can now run the Docker build command. Okay, so if I do that, if you say Docker images, in the images section, you will find all the images. Right now, I don't have any images. Docker ps will show you all the container. ps minus a will show you all the um, dead containers or exited container. So you don't see anything right now here in this local dev box. So the local dev box Docker is apparently very clear. So what I can do now, I can build a Docker image. And to build a Docker image, you just need to say Docker build and point to the file you want to use. But before I point to the file, I would like to also tag it, give a name. Now, when I give a name, I want to choose something which is relevant. So I can say docker.io. So I'm going to use Docker Hub, which is again a free option for all of us to really use. So I can say dockerhub.docker.com, and it asks me to log in. So any one of you can go ahead and create a login. And I have got few repositories. And you can see that the name of the repository starts with this. So I use this format. So the Docker tag, when I give the name, it has to have this name slash whatever the image name I want to give with the version number. So if I go back to my sample web thing and I say this is the name I'm going to use slash my demo web, and then I want to say version 1. Okay. Now what I'm going to do is that I'm going to keep it somewhere running into this. So I'll say this my sample web v1. Okay, so this is something I'm going to use so that I don't have to type it again and again. I just use this copied one. Okay, and then I use a dot indicating that my Docker file is here. Now you can see that it starts the Docker build process. This is the experience you will get anywhere. There's no new thing, but the only thing is that you don't have to install the Docker runtime, do not need those memory spaces, all those things. So it basically will download all the base images based on what is mentioned in the Docker file and then restore all of these. And there are steps involved. You can see that there are multiple stages in the process happening. And now after it is done successfully, if you say Docker images, you'll find a new image with the name I have given, right? So it's a sample where v1, that's the image I'm talking about. Now you can build a Docker container, run it locally using that same image. It's possible. But now what I'm going to do is that I'm going to push this image to this Docker hub. So this is where I need to push. Now, before I can push it, I need to basically log into this Docker hub from this command prompt. And this is also the same experience when you do it from your on-premises. So Docker login is the command, and then I use the username of my repository. By doing that, it directly points to the default Docker hub. That's the way it works. But if you have a different private repository or something like that, which has a different URL, you can always mention the URL in the command prompt and then point to something. If you don't mention anything, it assumes that you are going to use Docker Hub. Okay. Now this is going to ask me the password. So let me insert the password and then it will go through and then say login successful. Now what I need is that I need to say Docker push, and then here I need to push this image to my Docker hub. Now you can see that step-by-step thing happening, right? So there are a bunch of MBs gonna go uploaded into my Docker hub, and once they are done, you will find a new entry available called my sample web in that list of repositories within the Docker hub. Once this step is complete, you will be able to see that Docker Hub reflecting that into the website. Okay, so you can see that the thumbprint has come. Now this is the old one, four Docker images getting pushed over here. Now the fifth one will be visible as soon as I refresh it. So you can see that my sample web just a few seconds ago got pushed here. So I'm going to go ahead and use and create an container, a container running container from that. So I can choose many different ways to host the container. I can have the container running locally in my machine in a container runtime like a Docker engine, or I can host it in Azure Web App, which also supports container. I can use Kubernetes, any Kubernetes. I'm going to use Azure Kubernetes, which is a fully managed one, to host my container. Let's use the Kubernetes, because one of the good things about Kubernetes is that everybody knows how to host a container in Kubernetes, and then it becomes relevant because I don't have to really say anything new about Kubernetes. So what I already pre-created is that I have pre-created this Kubernetes, Kubernetes cluster in my subscription. So you can see that WGAKS demo is a managed Azure Kubernetes, and I can connect this Kubernetes cluster from anywhere by taking the certificate details. What I have done is that I'm going to use another browser experience, which is shell.azure.com. So if you use this shell.azure.com, it basically allows you to run the bash command shell from the browser. So you don't even need the WSL or anything of that sort in your local machine to run any shell command. So this is running. Now I use something called alias, which basically converts the kubectl into K. That's only to save the typing characters. So if I say K, it also gives me the same output. So they are aliased. Okay. So that's the only thing. Now every time I type K, it means that I'm typing kubectl. Okay, that's you just remember that thing. Now I say k create deploy. If I just create a deployment, which is a self-healing one, and then I say image. And what I'm going to do is that I'm going to use this image and then build a deployment. Now this needs a name, so I'll say deploy web. Okay, so you see that the deployment is created. Now I say k get pod, you will find a pod is creating. Okay, so if you go into the watch mode, it'll start showing you the running instances. That means the pod is running. Everything looks fine. I haven't really reached out to this pod to check how this pod is looking, but overall it looks seems fine. Okay, and then what I'm going to do is that I'm going to build something which will allow me to reach out to this pod using a public IP address. And in the context of cloud managed Kubernetes, we have a cloud controller manager, which allows you to build a cloud load balancer, which can give you a public IP address very quickly. Otherwise, on the on-premises scenario, you will have to build the in-rest controller, etc., on your own. So let's create that thing. So I'll say expose SVC, that's deploy. And then I say web, that's the name of the deployment. And then I say port. So I need to use this port 80, and our target port will be 5111. That's just remember that I highlighted that while creating the Docker image. And then I say type equals to load balancer. If I do that, it's going to go ahead and create a Kubernetes service object. So if I say k get svc minus w, you'll find eventually this service will have an external IP address. You see it's now in pending state. Sooner it will have an IP address. So this is the public IP address which it generates. Okay. So I am going to now copy this and open the browser and run just this URL. Okay, and you see that the sample web, which is basically the outcome of my application, is visible. Now let me go back and show you exactly what I did by making some small changes into my browser-based uh, development environment. So I go into this and go to this www root, not here, pages, and then I go to this index.ces HTML, and I go here a little down and I say that, hey, you know what? I'm going to say welcome version 2. Okay. This is the version 2 of my application. Now, because I made some changes, I need to rerun the Docker image building process. So I give this as a version 2. Now, let me just do this. So you can see that what I'm going to do is that I'm going to run the Docker build command with a tagging option, the version 2. Okay. Now this will start building that. Okay. And once this build process is done, what it's going to do is that it's going to create another version of the image in the list of images in the local box. So if you say Docker images, you'll get to see the version 2 images present here. Now what I'm going to do is that I'm going to push this image back to my repository, and you will see only one layer going because remaining are the same. So you say layer existed, only the small changes I made into my CS HTML probably is going there. So you see that Docker is very efficient in terms of how it uses bandwidth. Once this goes into that, and then you have this capability available over there, what you necessarily need to do is that you need to use that image to redeploy in the Kubernetes. So it typically has to happen through, let's say, a DevOps engine. But eventually, if you don't want to do that, and then you just need to do the same thing. I'll say that I'll run the same thing, but this time I'm gonna use this k create deploy. Maybe I'll give this deployment a name called web2. Web2 indicates the web version 2. And then I run the same command, that is expose. And this time I'll give the name web2 as the deployment 2, and it'll create a new service. So if you run the previous service watch command, you'll find the third service getting created, which will eventually have that public IP address showing up into that. So it is not going to replace it. Otherwise, in the DevOps kind of scenario, you will be replacing this existing one. So we're not discussing about that, but we are just trying to make some changes. So this is the older one, which I ran before, and this is the new one with the V2 appearing along with the welcome. So we'll find that if everything is fine and reflecting correctly, then the welcome will have V2. So that's the new change I made from the Visual Studio Code, which is running in the browser, and deployed that container, which I built from the browser, to this Azure Kubernetes service, all from browser. So it's all browser. Building a browser application, using Bash from browser, using Visual Studio Code from browser. So browser rocks. So thank you very much for watching. I just wanted to give you a glimpse that a lot of people complain about not having the developer setup, but you have all the setup ready for you. Just need to go ahead and embrace them. Thank you very much. Have a great, great day.